I welcome all the students to Pune College of Arts, Science and Commerce, Camp Pune 1. I teach statistics, paper 1, discrete probability and discrete probability distribution. Myself, I am Dr. M.B. Pathan. In last lecture, we have discussed theorems of probability. On the basis of theorem, we tried some problems related to probability. If theorem is applicable, we use it to solve the problems. And if theorem is not applicable, we draw the Venn diagram for given events. And with the help of Venn diagram, we try to solve the problem. Today, we are going to see the next part, that means problems related with probability of different natures. Let us see we have seen two examples in last lecture. Today we'll see some more problems. Suppose we have three events A, B, and C defined on sample space, that is omega, such that PA equal PB equal PC equal to 1 by 4. P of A common A intersection C is 1 by 8. P of A intersection B equal to probability B intersection C equal to 0. By using this information, we want to make a calculations probability A union B union C. Second bit, probability of A union C. Third bit, probability of A dash intersection B dash intersection C dash. Fourth bit, probability of A intersection C dash. Now, firstly, we'll try to put this information in terms of Venn diagram. You can see now what the information says to you. Probability of A common B equal to 0. This says there is no common between A, B. Probability of B intersection C equal to 0. It says there is no common between B and C. So when I will put event A, event B, and event C on a Venn diagram, in that Venn diagram, B and C should be separate, A and B should be separate. Then your Venn diagram will satisfy this information. If you come here, it says probability of A common C is 1 by 8. That means there is some common between A and C. So it tells you circle of A and circle of C, they have some common part. That implies your Venn diagram should be in this way. This is the circle of A, this is the circle of C, and there is a common. And this B event will be separate. No common between A, B, no common between B and C. That is, this information says. So from this example, we learned how to draw the Venn diagram for given information. I think everybody clear it. Now proceed for solution. I want probability of A union B union C. In last lecture, we made generalization of addition theorem from 2 events to 3 events. So this statement is with you from your last lecture. So probability of A union B union C will be PA plus PB plus PC minus P of A common B minus P of A common C minus P of B common C plus probability A common B C. This is your statement. Now put the values which is given in the question. So 1 by 4 is the probability for every event. P of common AC is 1 by 8. This rest is 0. So I put the values. Now you can see the last information is not in the question. But from Venn diagram, you can easily see there is no common between all these 3 events. So A common B common C is a null set, empty set, and probability of phi equal to 0. So we get answer probability of A union B union C as a 5 by 8. Now you can get this answer by another approach, not necessary by your theorem. I want probability A union B union C. So I write probability of A union C, this is union, plus probability of B, because as per my Venn diagram, union means total. This is A, C and B. I want probability of total of 3 events. So I will put probability of A union C plus probability of B directly from the Venn diagram. What is probability of A union C? You know the theorem. PA plus PC minus P of A intersection C should be there. Plus probability of B, that is 1 by 4. Probability of A is 1 by 4. Probability of C is 1 by 4. Probability of B is also 1 by 4. And probability of common is 1 by 8. This 1 by 8 by mistakenly plus, it should be minus. So you get 3 by 4 minus 1 by 8. Result will be 5 by 8, which is same as this. So this example teach you, you can go by theorem, and if you not remember theorem, you take the help of Venn diagram to solve the numerical problem. My next bit is probability of A union C, that is directly by addition theorem. Very easy. Write the theorem and simplify it. Now third bit is probability of A dash intersection B dash intersection C dash. How you can find it? It is equal to probability of A union B union C whole complement by De Morgan's rule. And that means it is 1 minus probability of A union B union C, and that is 5 by 8. So you get answer from this. P of A intersection C dash is also by yesterday's lecture. This is A intersection C dash. That means I want only this much part. So this is the part under study. So how you can get this answer? This will be P for A minus common part. So 1 by 4 minus 1 by 8, answer will be 1 by 4. So I put 2, 3 homework which you can solve by using Venn diagram and previous example which I took with you. You can see the video which is uploaded in your Google Classroom. Let us proceed ahead. Arrange the following probabilities in ascending order. Probability of A union B, probability of A, probability of A plus probability of B, probability of intersection. Now, how to solve such question? By using a knowledge of set theory, you have to decide which event is smaller than other. So firstly, ascending means increasing. So firstly, decide the probability of event which is the smallest than other, and then keep on increasing. So solution will work like this. A intersection B is a subset of A. We know from school set theory, intersection always smaller than original event. So probability of intersection less than equal to probability of A. Yesterday I told you probability of union less than equal to PA plus PB. A is a subset of union. So probability of A less than equal to probability of union. So what this discussion tells you, it says that probability of intersection smaller than PA, PA smaller than P of union, and P of union smaller than PA plus PB. That means these all probabilities we write in ascending order like this. I repeat again, A common B inside A inside union, and union is smaller than A plus B. So this is your arrangement of probabilities of these events. Next question, we have A and B, two events of sample space with given probabilities. Probability of A 3 by 4, probability of B is 5 by 8. Show that probability of intersection lies between 3 by 8 and 5 by 8. That means mathematically we want to prove this inequality. See how we can prove. One thing you can easily observe, this 5 by 8 is one of the value in the information. That means there should be some relation of B with A intersection B. Let us check how. A common B is subset of A, implies probability of A common B less than equal to PA. Also, A common B is subset of B, so implies probability of intersection less than equal to probability of B. What is probability of B given? That is 5 by 8. So I put it here. So I get a one side of the inequality from this condition. Therefore, you can make combination of these two, P of A intersection B less than equal to minimum of these two equations, and minimum is 5 by 8. Now next is probability of A intersection B, this given in the theorem, greater than equal to PA plus PB minus 1. Put the values and make a calculation. Result is 3 by 8. That is the lower limit of the problem. So from this equation and this equation, we satisfy your inequality. So this is the way of solving such numerical inequality. Now next question is, you have two events. I am purposely taking many numerical problems because you should not face a difficulty in multiple choice. A and B are two events defined on sample space Can the following statements be regarded as true? Justify your answer. So you have to say here, this information is true or false. If you say true, you have to justify how it is true. If you say false, again you have to justify why it is false. Now, first statement is PA 0.8, PB 0.7, and P of common is 0.8. Next information is PA 0.8, PB 0.7, and PA common is 0.3. If you look this, it looks very easily that statements are true both, but it is not happening in the true ways. First, it is a false statement. Now, why it is a false statement? You can justify A intersection B is a subset of B. So, probability of intersection is less than probability of B. What is the intersection? 0.8. Does 0.8 less than 0.7? Which is not. We know intersection is always smaller than original. So probability of intersection should be smaller than original. But here that is not happening. Here 0.8 and original is 0.7, which is a contradiction. And that is why the statement is false. So such type of justification you have to write. Now what you can say about second statement? It is 0.8, this is 0.7, this is 0.3. So it is smaller than this, smaller than this. So statement should be true, but not again. If it is these conditions satisfied, you try another calculation which can be developed by using this information. Let us check. Probability of union equal PA plus PB minus P of intersection. This is a theorem which is proved by us. Put the number 0.7, 0.8 and minus 0.3. Calculation coming 1.2. Recall your remark on classical definition. I told probability of any event should be between 0 and 1. So by using this information, calculation of probability is coming 1.2, which is not allowed. Therefore, second statement also false statement. So this is the way of giving the justification where the statement is true or the statement is false. So in this case, both statements are false. Question number 4. A, B, and C be three mutually exclusive and exhaustive events. Define on omega such that 3 times PA equal 2 times PB equal PC. This is the relation between probability of these three events. I want to find probability of A union B. Now, what is the probability of A union B? By addition theorem, it is PA plus PB minus P of A intersection B. But now I want to decide what is PA, not given in the question. What is PB, which is also not in the question, but relation is there. So by using this relation, we'll try to decide respective probabilities. Before that, I will make a Venn diagram by using the information. What information says? The events are mutually exclusive. That means all are disjoint. And next condition, they are exhaustive. So if I want to draw the Venn diagram, it will look like this. There is a rectangle labeled as omega. This is A, this is B, and the rest is C. That means omega divided into 3 partitions. That is named as exclusive and exhaustive. Other word is partition of sample space. The given events are mutually exclusive if there is no intersection pi. They will be exhaustive if I make a union and it comes omega. So if these two conditions satisfy, we call exclusive and exhaustive. That is happening here. A, B no common, B, C no common, A, C no common. And in all three there is no common. But if I add A plus B plus C, I get entire omega. So this is a Venn diagram for given information. Let us go ahead. Probability A union B union C equal to probability of omega from this diagram. So they are disjoint. So I put PA plus PB plus PC equal to P omega 1, because axiom number 2 says probability of whole sample space always 1. Now let us start. Probability of C equal to some number K. So if PC is K, then PB will be K by 2 and PA will be K by 3. So I put here K by 2, K by 3, K by 2, and here K. And I will try to find the value of K. So K comes to be 6 by 11. So this is a probability of C. What is probability for A? It is K by 3. So probability of union will be PA plus PB. There is no common because they are separate. So third part is not there. PA, K multiply 1 by 3 plus PB, K multiply 1 by 2. Simplify, that is the answer of the question. Simple questions, but you have to take a help of Venn diagram. Let us proceed next question. We have PA. It is very important question, little tricky question. I have probability of event 8.38, P of A common B common C 0.10, P of A intersection B complement intersection C complement 0.17, P of A dash intersection B intersection C 0.12. By using this information, question is asked, find the probability of the occurrence of at least 2 of the 3 events A, B, and C. That means we want to decide a chance to get minimum 2 events out of 3 events. So at least 2 means there is 3 possibility. You may get A and B, you may get A and C, you may get B and C, and the last possibility is you may get all of them. That means at least. So now firstly I will represent this data on a Venn diagram. A common B common C equal to 0.10. That means there is a common between C, B, and A. So circle of A, circle of B, circle of C are interconnected. So this is your Venn diagram for such type of information. Now I will put these values under the Venn diagram. A common B common C is 0.10. I put an arrow. This small part, you can look arrow, this circle, black circle is 0.10. This black circle is 0.10. Now P of A common B dash common C dash. Element of A out of B and out of C. So this is your probability. Element of A which is out of B and out of C, that is 0.17. What is here? A dash common B common C. B common C but out of A. B common C out of A, that means this circle, which I put value 0.12. So this is 0.10, this is 0.12, and this yellow is 0.17. Now what is 0.38? It is chance of entire event A. So this entire circle of A is a chance of occurring A in the experiment, 0.38. I think everybody understand how I explain this information on a Venn diagram. Now I go ahead to solve the question. What I want, you just time being you drop this. Come here. Probability at least 2 of the 3 events A, B, C occurs. How you will write? Probability A common B common C dash. So it's the chance of occurring AB. Probability A common B dash common C. So this is the chance of occurring A and C. Plus probability A dash common B common C. This is the chance of occurring B and C. And here probability A common B common C. Chance of occurring all of 3. Because I want at least 2. So when I want at least 2, I start from 2 and I go up till all possibilities. So 2 or more. So this is the addition of 4 calculations. Now I write 0.11, 0.10 and 0.12. Answer is 0.33. Out of these 4 calculations, 0.10 is with you. Where is the 0.10? Probability of A common B common C. So I have this value with me. Now this 0.12 and 0.11, from where it comes? It is the addition of these 3 events. 0.12. This is your 0.12. What is this? It is common of B and C outside A. So common of B and C outside A. So this is 0.12. Now how it is 0.11? This is addition of this plus this. How you get this? It is from here. P of A is 0.38. From 0.38, I subtract 0.17 and I subtract 0.10. So this plus this, it is A common B outside C. A common C outside B. This plus this is equal to 0.8 minus 0.17 and minus this 0.10. So answer is coming 0.11. So this is the way of taking a help of Venn diagram to get your numerical answer. If anybody is not getting, again try on the rough page, draw the rectangle, draw 3 circles connected, put this information in proper place and try to get this separately. This is given in the question, this is given in the question, this plus this is 0.11. That means this plus this area is 0.11. Easily you can see from the Venn diagram, 0.17 and this middle circle is 0.10, become 0.27. 0.38 minus 0.27 is 0.11. So addition of these two probability is 0.11.